All right, so I'm back working on my my little MVP of a Read It Later app. And what I want to do today is to hook up the Haskell backend to a database so that I can begin implementing some of these handlers, which are going to write and or read from the database. I set up a little Postgres thingy-majiggy just running on localhost. It has a database, I guess, called Lector. And I guess I need to create some schemas. I'm not really even sure how all the schema stuff works. I'm not super familiar with Postgres from a user point of view. But so let's do that. And one thing I want the database to have is a like a TaskQ, which I think is basically just has some standard queue structure and then uses advisory locks instead of whatever the real locks are called, so that you get faster behavior. And so let's see if I can do that. Give me a second. All right. Okay. So, let's see. So first of all, I need to know what a reasonable task queue structure is, and I'm not really sure. And I'm just going to ask the internet to tell me. I think for Postgres, you want like one database and then multiple schemas. Let's see if we have a schema name. Maybe I'll call this. So I want at least two table-like things, two, I guess, maybe schema-like things. One is something to serve to hold the metadata for things like what are articles called. And maybe I'll call this app data or something. And then I guess I want another one that has that's TaskQ. I don't know if this is the right thing to be doing. And then so I'll just ask Bard in ChatGPT, or maybe I'll start with a search, PostgreSQL, TaskQ. Procrastinate, PostgreSQL-based task queue for Python. Devious SQL, how to implement a distributed job queue using PostgreSQL. Let's look at this Stack Overflow answer, just to see what people are doing. This was 6 years ago, so things have probably evolved since then. Is there an answer? You need to use clock timestamp if you want to have actual time when query is executed inside the transaction. Now we'll always have the same timestamp at transaction start. So what is this? It says subtasks, inner join tasks, task ID, etc. All right. That seems more complicated than I want it to be. About queuing. And maybe let's take a look at what procrastinate looks like. So queuing in core, is it a table? Concurrent inserts and pruning. Very common design pattern. Parallel queues have different transactional semantics. They're looking for additional maintainers. So they have this task queue that I guess is like a named queue. I'm not sure if we get to see what their queue database looks like. Demo. Maybe in here. Maybe it's in scripts. I'm just looking for like what tables and whatnot to have. Maybe Bootstrap. Are there any SQL files? Python. Whatever this PG SQL. I guess this is like Python something Postgres SQL. Oh, here we go. SQL. This looks promising. Wait, how about schema? Schema.sql. They have job status, which is to do, doing, succeeded, or failed. And then a job event type. Deferred, started, deferred for retry, failed, succeeded, canceled, scheduled. And they have this jobs with a big serial as primary key. I'm not sure that I know what a big serial is. They've got a queue name and a task name and a lock, which is text, and then a queuing lock and some JSON args, I guess. And then a status, when it was scheduled, and how many attempts there have been. This is this seems reasonably well thought out. There's this defers thing. I guess this is keeping track of things that have been deferred. There's a primary key, a task name, the deferred timestamp. Is the task name how it joins with the procrastinate jobs? And then, oh, no, we have a job ID. Yeah, I'm not sure. Also, what is a job ID? Oh, sorry, the big int is the type. I was thinking this was the type. Okay. And then we have events. So it's going to emit some sort of events. And here, I think we already looked at this. Okay, so that's reasonable, but that's maybe way too complicated for my needs. So let's ask, how would you create a simple task queue using Postgres? And I'm going to also ask ChatGPT. ChatGPT 3.5. So Bard is saying that I should have an ID, which is a unique identifier for the task, a queue, the name of the queue that the task belongs to, the data for the task, and the status of the task, pending, running, finished. Create a function to insert a new task in the queue, etc. Here's an example of a simple one. I'll say, could you give me the SQL command to create this setup? So here we have in ChatGPT, we have the create table task queue that has an ID serial as a primary key, a status, which is varchar, which is basically like a variable text, I think. So status doesn't have a enum field to it. And then data is JSONB, which I guess is some JSON type. So here's an example. So they're saying insert into task queue. The value is task type example, parameter 1 value, parameter 2. And then you can dequeue tasks. That seems reasonable, except I don't like this like string type things, because that means that essentially the database doesn't have the structure. The structure is in whatever things are parsing the JSON. And so here's what Bard says. We have some ID, a queue, which is varchar. Data is JSONB. I guess people are using JSONB for everything as essentially like a document that you can store in the table, and then a status, which has the string pending as a default. Okay, that's cool. So let's see. What I don't like is I like the Python project we just looked at, whose name I now forget, that had had actual types for like an enum type for the status, and the table will have, and this said something about JSONB, which I wanted to read. JSONB data type is used for data column. Okay, so let's just verify that JSONB is what it seems like it probably is, which is some JSON bytes. There are two types for storing JSON data, JSON and JSONB. They accept almost identical sets of values as inputs. The major practical difference is one of efficiency. The JSON data type stores an exact copy of the input text, which processing functions must reparse on each execution, while JSONB data is stored as a decomposed binary format that makes it slightly slower to input due to added conversion overhead, but significantly faster to process since no reparsing is needed. Yeah, okay, so JSONB sounds nicer. Coming from working with protos, it would be a little bit nicer to have actual protos, but I think that there's no way that this little app I'm building will really be significantly impacted by the need to convert protos to JSON. So maybe that's just an acceptable thing, because I think JSON B should be built into Postgres at this point. So that's fine. That's good. That's cool. Although the thing I installed in Linux Mint was 16. Does 14 have JSONB? It seems to. Okay, seems good enough. So I like this. Do I want the TaskQ to be this flexible? Or do I want to? So like the main thing I want the TaskQ to do, which I talked about in the previous video, is I want you give it a URL, and it eventually fetches the things that it's supposed to fetch. So I guess I do want it to be relatively general. There's a part of me that wants to just stick the URL in the TaskQ table as an alternative to sticking in the data as some JSON object. But I guess in practice, what I'm going to do is create some proto for the task stuff and send that into the data as JSON and pull it out and just use that as the communication mechanism. So the protos will give me like an actual type information and all that stuff. And then what about status? Pending, running, finished. And I'm wondering if this is something that I can just, instead of storing a string, can I store something that is like an int? There are these long-running operation protobuf things that I think are mainly used in clouds. Is it only in cloud? Let's see if we can find some other URL. Cloud. Google API Core. So their API is operation, refresh, cancel, retry. Can I look at the actual proto file? Oh, it's Cloud Python. Okay, so this is This is still cloud stuff. Let's just look at what they do for cloud. Because I think that even though this is cloud, I think this is most likely essentially the external version of what they use internally, which is presumably well thought out and is consistent with all the other stuff they do with protos. Really, I just want the .proto file. Here's the spanner one. Does spanner have their own operation type? So their operation method has a name, some metadata, which is an any prototype, which is service-specific metadata associated with the operation. It typically contains progress information and common metadata such as create time. Some services might not provide such metadata. Any method that returns a long-running operation should document the metadata type, if any. And done, which is just some Boolean. Error in response. So I'm guessing that maybe this is not the easiest thing to use. It seems to be, at least initially, I can't find like a clear entry point that's not tied to something specific like the Python APIs or a spanner. Maybe this is it. This appears to be a proto file. You can list operations, get operation, delete operation, cancel operation. Wait. And does this have, so we have done, but do we have any other list operation requests? Oh, these are just the requests. This is the RPC service up here, right? I don't think we have any other status information, like pending. We have RPC status, which is different. We have canceled. Yeah, do I want to use this? I'm not sure. Let me think about this for a second. So for the status, I could just implement my own status, I guess. And how did that Python library do it? It had some sort of types. Wait, is this Hacker News thing any good? Procrastinate was the Python thing I looked at. This looks useful. Do we get a table? Q, a Ruby gem that uses Postrest's advisory locks. Maybe Q has an interesting. I guess I should bookmark these so that I don't forget where these things were. All right, so where do we think the SQL is? Maybe in scripts? No? We have this gem spec. I don't know anything about Ruby. I don't think it's an auto. Maybe bin? Doesn't look right. How about lib? Lib is promising. SQL spelled out. Model.rb. Okay, this looks pretty promising. We have things like tables. And I guess we're using JSONB for something. error count, expired at, finished at, run at, qualified table. I guess SQL is maybe a Ruby, what's the word? SQL library. Migrations. Is migration 1 the first SQL thing? So we create table queue jobs with a priority, run at timestamp, which defaults to now, the job ID, and the job class, which is text, args, which is JSON, but not JSONB, and error count in the last error. And then what is down? Drop table. Oh, okay. Let's just peek at one other random folder. Okay. So then going back to procrastinate, I just wanted to see what they did with their types. I think schema. Okay, so I guess Postgres has this enum thing on its own. And presumably this does something like each one is an int or something internally. And this to do is basically pending. Doing means it's running, succeeded and failed. And then job event type, deferred, started, deferred for retry, failed, succeeded, canceled, and scheduled. I guess I should have thought about this a little bit before I started digging in, but for just in the interest of doing something, I guess what I want to do is store the type as. I mean, do people like Postgres enums? And then how do you consume a Postgres enum? Like in Haskell. Are data types that comprise a static, ordered set of values. They are equivalent to enum types supported in a number of programming languages. Maybe I'll ask Bard. So tell me about the performance of Postgres enums. So we do storage space, improved query performance. Okay, so it helps with the indices. That's a good point. Reduce data validation overhead. Reduce flexibility, additional complexity, limited support, and some ORMs. Yeah. But if I have locks, then and can't you tell that a job is being taken by something else by just checking that it's locked? I'll say explain how I can use advisory locks to implement my Postgres TaskQ. So create a unique identifier. When a worker wants to process a task, it should acquire an advisory lock on the task. The worker can process the task. When the worker process is finished, it should release the advisory lock. You do try an advisory lock, I try advisory unlock. So they have this insert task thing. And then some polling functions. So they're just going to poll the queue. And here's the query. Status is pending. So they do have a status thing. And then we call process that task. If not locked, the lock is not available. We cannot process the task. I think this is opposite. You want if locked, I guess, basically, right? Depending on what this returns. At least the variable name should be the opposite way. And then when you're done, you release it. Okay. And so pending, failed, canceled, and completed. Is that all I need? Or should I save completed? Should I? Should the enum know whether the task succeeded or failed? Does it care? I guess it should know. Yeah, like how do I want to handle retries? I guess what I wanted to do if it fails for, yeah, I guess basically that I do want it to retry a little bit, and then if it fails a lot, I want to know that it failed and have some sort of information about how to debug the failure. So it seems like this procrastinating thing is like reasonably good. But do I need a queue name? Let's see if we can do without a queue name. And what did they say about retries here? All right, so I guess I'll ask, how should I handle retries and transient failures? Maybe I should just use some other library, but I kind of don't want to add it. Don't want to add a dependency on some other project. Implement a retry policy that specifies how many times to retry a task before giving up. So maybe retry and back off could just be part of the thing that handles it, and then we could just have a like a failure count that that has some stuff. Okay, so maybe this shouldn't be a separate schema. Maybe it should just be a table, but okay, so I am just going to have one schema and multiple tables. Is that advisable? I don't know. I'll do it this way. I don't know about the table space. I've never used dbeaver before, but I assume that this is something I can figure out. Constraints, foreign keys, indices. Here's property. Oops. Did I actually succeed in creating a table? I just want to execute a SQL query, I think, right? Is there a way to do this? I mean, this UI is nice and all, but is there a SQL view? Is that what's going on at the bottom? I can do view columns. Oh, I can add column names here. Is this what I'm supposed to do? Oh, weird. I don't want to do that. So what I do want to know is the difference between serial and big serial. So 4 versus 8 bytes. I guess how much does it matter? I don't know. So is it more common to use serial or big serial for IDs? It's more common to use big serials because it can store more. However, sometimes you want to use serial. Yeah, okay. So let's actually create a SQL statement. I'm going to see if Bard will just do it for me. So it made this one. Let me ask the question, how do I know when I should create a separate schema in Postgres versus just having a separate table? They say you should create a separate schema when you need to group together related tables and objects, or when you need to isolate tables and objects from other users or applications. Is that because like the schema is more of a unit of policy? Here's some examples: to group related tables, to isolate tables, to implement multi-tenant databases. A multi-tenant database, you can use schemas to implement multi-tenant databases by creating a schema for each tenant. Okay. Here are some examples when you do not need to create a separate schema. You only have a few tables. The tables are not related. The tables are not related to each other, then there's no need to group them together in a schema. And the tables do not need to be isolated. So like what if I have two unrelated, what if my database has only two unrelated tables? Should they be in the same schema because it's a small database? Or should they be in different schema? Technically schemata, because they're unrelated. It's best to keep them in the same schema because it's simpler to manage and maintain a database with schema. Okay, great. All right, so let's do that. Let's get rid of whatever I did with the schemas. Let's just nuke them. Can I delete them? And let's look up the Postgres public schema. Yeah, okay. Seems like things typically go in the public schema. So I'm just going to reuse the schema, create some tables. And the first one is going to be called TaskQ. Actually, no, I'm not. I'm not going to do this. I'm going to use this create statement. Let's grab the create statement they created. By they, I mean Bard. and I guess edit it in Emacs. I guess I'll just call it create.sql. And we'll create the table TaskQ. Bard told me big serial was better, right? I think I have fixed my caps lock key on this VM. Let's make caps lock control. Okay. All right. So they have Q as a varchar. Do we really need varchar? What did ChatGPT use? Did they use varchar? They did use varchar. What did procrastinate use? Character varying. I guess it's the same as varchar. All right. So I really don't want a Q name. Some maybe I maybe I do. I'm just feeling indecisive about whether I want to have a name. I'd like to make it simpler if possible. And then status is going to be this enum thing, which I'm going to start by just taking their this enum just for the syntax. And at least in like C++, enums are often capitalized. So I want to see if there's other examples of enums from Postgres to see if there's any common formatting patterns. It seems like they're typically lowercase. And I think status is fine. And these are separated by commas. I'll have and I guess do we not that this really matters, but I'll say for performance, how should I structure the enum? How should I structure a Postgres enum? I assume that the things that I'm assuming you want the top value to be the thing that you're most interested in. Does order matter for query speed? And if so, do you want the most common values to be at the beginning or end? So you should structure it so that it minimizes the amount of work that Postgres needs to do to evaluate enum expressions. You should avoid using enums with a large number of elements. You should order the elements in a way that makes it easy for Postgres to find the desired element. Yes, the order matters. It uses a binary search to find enum elements. A binary search is, if they are not stored in ascending order, then it will need to perform a linear search instead. Oops, we don't want that. Generally put the most common values at the beginning. This is because Postgres will typically need to search for the most common values more than it needs to search for the less common values. For example, if you have an enum that represents the status of a user account, then you might want to put the most common values, e.g. active and suspended, at the beginning, So make it faster for Postgres to find these when it's evaluating queries. Okay, so let's do pending completed and failed. I guess let's try that. So here's the syntax for the consuming the enum in the create table query. Might I have a type that's the same name as a table entry thingy? I'm not sure. Maybe I'll just call it status T. Not null. And the default is pending. And then I guess I'll have some column saying whether it's failed. And maybe, let's see, I guess failures as some sort of int type. I'm not sure what int types there are. Numeric types. Small int should work. So is there like a way to do a default? Does I'm not sure if the default syntax works. I guess it does. Not null. And then default is 0. And I guess I can just pack the failure information into the JSONB. I call this job proto to remind myself that's going to be like a packed protobuf. All right. So here's the TaskQ. I'll ask Bard to critique this. Design for Postgres TaskQ. So it's got some pointers. Like the new, which I stole from somewhere else. This is a good choice. Okay, the JSONB. So it likes, okay, so what does it not like? You might want to consider a created at column. Yeah. Okay, so let's do created at is a good idea. And it should be some timestamp time, which I'm just going to copy from. With time zone. Is this a real thing? You might want to consider adding a worker ID. That could be helpful, but I'm not I'm not planning anything fancy enough to have multiple worker IDs at this point. And a retry after column to the table. That could be used to specify how long to wait. I guess that's fine. And I assume that timestamp is the same thing. Using default as the status is a good idea. Okay. No major concerns. Thanks, Bard. Your appreciate your confidence means a lot to me. So okay, so how does this change look? I've added the suggested created at and retry after columns. Does the use of timestamp with time zone follow best practices? Okay, it's a good improvement. Is a good choice overall. A few more thoughts. We want to consider making it not null. Yeah, okay. Where's the procrastinate thing? Yeah, not null is good. I feel like retry after can be null though, because you may not want to retry ever. There's always a restart policy for each task. I'm going to leave it null. And I might want to consider updated at for auditing and debugging purposes. Okay. Yeah, sure. Cool. All right. So that's, I guess that's a reasonable task queue. What else can I do? That took a bit longer to, to put together than I thought it would, but not entirely surprising. I had some question in my mind, but I kind of forget what it is. Well, first of all, let's call this let's make this create task queue.sql. And get rid of the original create.sql. And let's create a new one for create app data.sql. And this will be so we'll need like a table for articles. Is that all we need? And before we do this, Postgres naming convention plurals. Whoops, I misspelled plural there. But I forget whether names are supposed to be plural or not plural. Choose a convention and stick to it. Maybe there is no standard convention. I'll say, should SQL table names be pluralized? Be plural or single? Singular? For example, should I name my table dogs or dog? They should be plural. That's because a table typically contains multiple rows of data. It's important to use plural data names. Is it really important? Is it clear that the table contains multiple rows of data? I feel like that's pretty clear. It's easier to write queries that involve multiple rows of data. It's consistent with other things like columns and views, users, products, transactions. Here are some examples of bad ones. Yeah, let me ask ChatGPT what they think. I mean, if the AI overlords all agree, then I guess. It's a matter of convention and personal preference, and there's no strict rule. At least Bard had the guts of just going for it. So singular names are often preferred by proponents of the singular naming convention. They can be more intuitive in thinking about each row in the table as representing a single entity. They may lead to cleaner and more readable SQL queries. Be consistent. All right, so I'll say which convention is more common in modern apps. Singular names are commonly used by ORMs, like Ruby on Rails. Some developers prefer single names. Plural names are widely used in other programming languages. Huh. Let's see if there's a website. The correct answer is there's no right or wrong answer. There just seems to be no universal answer. Academia has it the table name should be singular of the entity that they store the attributes in. Academia says that? When did they say that? I'll bet if you put a label on a sock drawer, you'd call it socks. I prefer to use the uninflected noun, which in English happens to be singular. Reflecting the number of the table name causes orthographic problems, as many in the other answers show, but choosing to do so because tables usually contain multiple rows is also semantically full of holes. This is more obvious if we consider a language that inflects nouns based on case, as most do. Since we're usually doing something with the rows, why not put the name in the accusative case? We have a table that we write to more than we read. Why not put the name in dative? It's a table of something. Huh. I don't know. I don't know that that's really compelling. So select customer.name, customer.address versus customers.name. The latter. So I vote for singular. I guess so. Yeah, let's do singular. Let's try singular and see how we feel. Okay, and somewhere I have a proto. Let's see what I was saying that I was going to put in the database with my proto. We'll definitely have a URL, which is maybe just a varchar. but maybe there's something that I need to think about. If by links you mean links to web pages, I'm guessing you want to store the URLs. Yeah, varchar. Okay, so I forget the varchar syntax, but we'll figure that out. So a URL, maybe all the created at, updated at, and I guess fetch job will be the job ID. And then we can have a, I guess we can have like, no, I think we want things like author and time to read, which should be some sort of int. Where's the numeric data types again? I guess realistically it's going to be in just minutes, right? So okay, I think integer is big enough to handle how many minutes something is to read. $546. For most things, that's probably fine, but then somebody's going to try to add like the collected works of Euler or something. That might take longer than 546 hours. So maybe just to be on the safe side, we'll use integer. And what else do we need? First of all, let's separate these. Put the metadata e-columns up at top. And then the bookkeeping columns kind of down at the bottom. The time to read is going to be some integer. Author progress. Reading progress is, I think, going to be an integer. Set of progress. Offset was going to be a uint64. So you want some int64. Which I think should be a big int, right? What else do we want? Maybe you can take a look at what Wallabag does, since that's kind of the comparison point for me right now. Data, DB, maybe? Maybe that's where the data is stored. Maybe scripts or app or bin. Let's try app. I guess these are version, and then they have the year. Here's a create table statement. me see if there's a better way to view this. I'm gonna just grab, I know GitHub won't let me search anymore, but let's just clone it into temp. All right. So we have these PHP migration things. Do you have anything else? That seems to be about it. All right. Unfortunately, it's a little bit unreadable, but let's try it. Where were we? I think app, doctrine migrations. We have name, which is varchar, value, but I don't know what value is, section. And then we have things like tagging rules, tag, entry. Oh, the first one is some config setting. Entry, I think, is what I want. We have some integer, I guess, for the ID, the user ID of the user that's using it, title, URL, whether it's archived, whether it's starred, the content of the article. That would be good to save, except we're not going to save it in the database, I think. When it was created, the MIME type. Maybe language, domain name, preview picture, whether it's public, and then some foreign key constraint stuff. So title seems good. Title will be some varchar thing. And I guess whether it's archived might be important. Do we want to record when it was archived? Maybe that's not so essential. Okay. That should be good to get us started. Didn't I have something varchar here? No? Okay, so I just need the syntax. I think I put in the parentheses like with the size or something. Varchar like 255. Okay. So the URL can't be null. Title can't be null. Can the author be null? I think so. What do they do? So they allow the title to be null and some other stuff. What does clob do? Is it something about clobbering? Clob data. Variable length character data. All right. So I'll allow title and author to be null. Time to read. I guess that can be null. Let's have reading progress to be not null and default to 0. Whether it's archived will be bool not null. Is it bool or boolean? Boolean, I guess. Is big int not recognized? Let me double check the unsized and 64 size. 2 to the 63 minus 1. 2 to the 64 minus 1. Yeah. This seems to be good. Big int seems to be good. And then created at, etc. We can just grab from here. And the fetch job will be some ID, some foreign key. And let me look up the big serial type again. Large auto incrementing integer. So when I refer to it in a foreign key, do I still refer to it as big serial? The sad funcionaro F key. Yeah, I guess I do. Will I go to SQL jail if my types are not uppercase? Maybe I will. Okay, so the fetch job is going to be this big serial. Let's see. I mean, do I want to store this fetch job forevermore? Maybe I just no, I don't think I do want to store it forevermore. Maybe what I want to do is store the path on disk as and I guess I will know that if there's no path on disk and it hasn't been fetched. I guess let's try that. And I guess we'll make the types uppercase. O, 2. And I don't know about this time zone stuff. Okay. And we're missing a bunch of stuff, like how do we want to think about multiple users? Um, and I'm going to deliberately leave that out. For one, I don't know. For example, Wallabag stores the user ID in the article table, which kind of implies that a given instance will store multiple uh, uh, a multi-tenant instance will store the different tenants articles all in the same table. That may be okay, or I may want to make it so that there's more isolation between the different users. So I don't want to build that into the database at this point. And also I haven't whatever I use for users, I want to be able to apply that across multiple apps rather than just this single app. So I want to make sure that those types and everything are worked out properly and aren't just like added willy-nilly. So I'm going to commit this and say draft create SQL statements for our lecture backend tables. And it would be nice if these commands execute. So let me see if there's a way of running the SQL. Open dashboard? No. Database tasks? No. I can search. Here, SQL. Can I click on this? Here we go. I guess so. So I can paste this, and then what is, so the play executes a SQL query, and then the play plus executes it in a new tab. I'll just try play. What? Syntax error. First of all, there's a space here. I don't think that matters. Did that work? I'm not sure. Am I missing a comma or something here? It seems to think that this is not valid SQL. I think it created the status type. Is it because there's an extra comma? Okay, seems like maybe that succeeded. Can I view columns? No items. Okay, so it seems to have created, I'm not sure why I don't maybe see it in here. In schemas, public tables. Wouldn't there be the TaskQ table? All right, whatever. Then I'm going to create this other table. Oh wait, first let me make sure that I think that this was the error. This I'm less confident is valid syntax because I wasn't very careful when I made it. Oh, and I probably also have this trailing comma. Okay, so it thinks that this created successfully. Let me make sure that I update my git commit. All right. And so I would like to know that this is really here. And I'm just not sure how to use this dbeaver thing. Let me try logging into using the command line query thing, but I might have to enter my password. So why don't I blank the screen for a second? Okay, so if I do, I think I could just use the lector database. Okay, so this seems to exist. And what is it? App data? App data does not exist. Oh, article. Okay, so this database seems to exist. That's good. Everything is cool. But we are now an hour and 20 minutes in. I'm trying to keep these relatively short so that they're not too overwhelming. And so I think I'm going to leave it here. The next logical thing to do, which I guess I'll do tomorrow, is to begin adding some. I'll have to import the Haskell Postgres library and configure connectivity, which might itself take about an hour or so, just because I haven't used the library before and I might run into issues. And after that, we can begin like writing and retrieving stuff from the database. And the last thing I want to do before I go is to look up advisory locks. Like, do I need to have the lock as a row in the table? So my TaskQ design, if I want to use advisory locks, do I need a lock column in the database, or are locks always available in the table, I guess? You do not need to lock a column in the table to use advisory locks. Advisory locks are global locks that are managed by the PostgreSQL server. That means you can acquire an advisory lock on any object in the database, regardless of whether or not that object has a corresponding column in the table. Okay, cool. The other thing I don't know is whether Postgres Simple supports advisory locks. And I'll have Bard critique my my article table. So I'm creating a table to store articles for a read it later app. It lets you read web pages that you've saved. What do you think of my table design? So it's giving me some stuff it likes. Am I using a new for the is archived? It should be a Boolean. What are you talking about? So then it's got some advice. May want to consider adding tags to the table. Yeah, I don't care about tags or notes. Yeah, tags and notes maybe, but those are not features that I think that I want to support for the MVP. Adding a deleted column to the table. To help users manage their articles and avoid losing articles they are interested in. That's a fairly good point. I'll call it soft deleted. Does that work? Let's start by deleting this article table. And then see if this is the right syntax. Okay, sounds good. Okay, so that's that. And then maybe before I go, I'll check to see if PostgreSQL Simple or Haskell supports advisory locks. Do we have a, here's the repo. Maybe I'll see if SourceGraph can search it. What is it? PG acquire advisory lock. Try advisory lock. Nothing. Oh, I guess it's a part of the, if it's just part of the SQL statement, then maybe maybe Haskell doesn't need to know about it. Yeah. Okay. All right. Sounds good. So I'll be back tomorrow doing, I guess, trying to hook up PostgreSQL simple and seeing if things work. And then I'll do some code reading on Friday. I haven't exactly picked which repo I'll look at, but I'll decide that soon. Thanks.